All right, so now we're going to talk about functions and quotient manifolds. So a function f on the sort of total space is invariant. Okay, under the equivalence relation, if the following is true, if f of x is equal to f of y, whenever x is related to y by the equivalence relationship. Okay, and if you do that, then this induces a well-defined function on the quotient manifold. So, right, this induces a well-defined function, let's call that f tilde, okay, on the quotient manifold, which is called a projection. Okay, such that the following diagram commutes. Okay, so you have a map from the manifold to the quotient manifold by the canonical projection. You have the function f, map from m to n, for example, and then you have f tilde here. Okay, so this diagram commutes, right, which basically means that f is equal to f tilde composed with pi. Okay, and then you can say something about the smoothness, it's like of these functions using the following proposition. Okay, so let m quotiented by tilde be a quotient manifold. And let f tilde be a function on this quotient manifold. Then f tilde is smooth if and only if, in some sense, the lifting f, which is given by f tilde composed with the canonical projection, is a smooth function on M. Okay. All right. So again, it's like the point is that in the context of the, it's like our discussion of optimization on manifolds, part of the motivation for studying quotient manifolds is when you have, say, cost functions or loss functions from a manifold, it's like, say, to the rails, with the property that that cost function is invariant under some sort of equivalence relationship. Okay, and as we've discussed before, what the consequence of that is that it makes the, at least if the equivalence class associated with this equivalence relationship is, it's like is actually a manifold in that sense. It's like, and it's not, it doesn't have isolated points. Then what happens then is that obviously the minimizers would not be isolated as well. And so that poses problems numerically, oftentimes, certainly from the point of view of the conditioning, it's like of the numerical method. So what we want to do instead, right, is then instead of thinking of the optimization problem on the total space, we want to think of the optimization problem on the quotient manifold instead, right? So So that's sort of one particular instance where it's like you want to relate invariant functions of the manifold with functions on the quotient manifold instead. Okay, so let me just stop here for a minute.